All right, so we reviewed Vertex form today. We were first introduced to it yesterday. I am not providing you the formula for this, so you would have to know the formula. Let's see. Table 6, can you tell me what the formula is for Vertex form?
Then like A parentheses X plus H parentheses plus B.
Okay, class, what do you think? Stella?
AX squared plus BX plus B.
Okay, ax squared plus bx plus c is what form? No. Ax squared plus bx plus c is our standard form. Vertex form, would you guys agree with what Parker said? What's wrong with it? There's stuff that's wrong with it. There's some stuff that's good about it.
You need to have a squared after the second parentheses.
You do need a squared after this part, yeah. Is that all? It's K instead of this B that's right here. And is that it? Is it perfect now?
Y.
Okay, y equals. You guys all agree with it then? So actually, it's supposed to be a minus h in the formula. So start committing it to memory, maybe put it on a note card. There's not a lot of things you have to memorize for this unit, but maybe memorize your Vertex form, your standard form. There's not really a form for your factored form, but I guess you could maybe make some flashcards on how to multiply those out, how to identify the zeros, all that stuff. But each form has its pros and cons. What can I see best when it's in Vertex form? The Vertex, what letters will tell me the Vertex? HK. All right, remember that the true value for H always looks different than how it looks in your formula. So that's why I always know it's X minus H, because that's what makes it confusing. And then the K always matches, right? So there's that. What can we see best when it's from standard form?
Or your X.
X-intercepts you can best see from factor form. So I don't really have a structure for factor form, but here's like an example. When it's in that format, you can clearly see your x-intercepts. What would be the x-intercepts of this random example I made? 7 and -2, good. So that you can see best from factor form. Anyone remember what we can see best from standard form? The C tells us what feature of the graph. So in factor form, we can see the x-intercepts. Vertex form, we can see the vertex. Standard form, we can see the y-intercept, which is also known as like that starting the mouth. Good. Okay, so that maybe put on some flashcards. Maybe you can find some that are already made on Quizlet and help you study that way. But yeah, we just had this little lesson to do. It was lesson 17, not too bad. You do have a puzzle piece for it. I'll go make sure that it's in all the algebra classes right now. And yeah, please ask me questions. Tomorrow we are doing a binder check in algebra. So if you have me for algebra, listen guys, if you have me for algebra, you can probably make sure your binder's ready for tomorrow. And then start working on resubmitting this coloring activity if you haven't. And then working on the study guides. Both study guides are available now. So if you don't have me for algebra and you need access to those study guides, let me know. But my algebra students, you should see it at the very top of Schoology, right there. Can't miss it. So please look just like the test. I don't think anyone really should have free time because we should all be diligently working on all those things. But any questions right now? Okay, so I'll go make sure that that's enabled in everyone's Schoology, the lesson 17, but if you need something else, please don't be shy. Or on the lesson 17 practice, we are selecting all equations with a graph whose vertex has both a positive x coordinate and a positive y coordinate. So what would be the vertex of our parent graph? What does vertex mean? The turning point of your U. So for my parent graph, like my most simple quadratic function, where's that vertex at? X squared, when you graph it, where's the vertex? It's at 0, 0. And I could show you that, but I've graphed it for you a bunch of times. That was always our starting point for all the transformations. That one has a vertex at 0, 0. 0 is technically not positive or negative. So you're not gonna pick this answer because 0 is not positive or negative. We want ones that have both a positive x and a positive y. So then what's the vertex of this one? Note that all of these are in vertex form. So if my vertex is given by HK, 1, 0 is my vertex. Again, the 0 makes it not positive or negative, the 0 is not. And we want them to be both positive if we're selecting them. Does that make sense? Now the next one, table 6, can you tell me what the vertex is? It should be positive 3, positive 2. So the H is always different of how it looks. The K always matches how it looks. So this is our first one where both coordinates are positive. So we're gonna select that one. Table 7, what's our coordinate for this one? So then we're not gonna pick this one because we want them both to be positive for this question. Table 1, what's our vertex for this one? What would our H be? It would be -2. H is always opposite of how it looks, so we're not gonna pick that one because 2 is negative. Table 2, what's my vertex for this one? Good, so we are gonna pick this one because both coordinates are positive. And, let's see, if I want to pick it. Table 3, what's my, vertex for this one? Vertex for this last one? It should be a positive 1. The H is always opposite of how it looks. K is not. So 3, 1 is that vertex, so it should be these 3 answers that you selected. They could be shuffled on your screen, so you know. And it looks like the key is wrong, so let's see. Let me make sure I'm not making a mistake. Don't think I am, but let's see what the keys, wait, I am selected. Okay, now let me see if the key is right. Okay, no, the key is right. So it should be those 3. Again, they could be shuffled, so you should be picking the ones that The H looks negative, but it's actually not. X minus a number, the H is positive. And then the K is also positive. The questions on this one? Like this question. Okay, questions on others, Chevy? Number 5 on today's? All right. So then, number 5 on today's practice. We have the height in feet of a soccer ball is modeled by this equation, where time is in seconds after it was kicked. We're gonna match the number from the equation with what it represents. So remember this fact for any sort of projectile motion problem. They're usually in this format. So -16 t squared plus v times t plus s. Where does the -16 come from? Or really, I should say the -16 t squared as a whole. What's that affected by? So that -16 has to do with the effect of gravity. Anytime you see that in a problem, projectile motion problem usually is when you see them. That is affected by gravity. The rest, what does V stand for? Velocity. And it usually won't say V, it'll usually say a number, but the number that's in front of the T, the T is gonna be my velocity. Would it be upward or downward velocity? If they're kicking a soccer ball? Upward. So upward velocity for when the ball is kicked. And then the constant, and of course they changed the order, but you guys should still know the single number in your projectile motion problems is your what? Y-intercept / your starting height. So it looks like the ball was kicked to be in the air. So height of the ball when it was kicked. All right, questions on it? So if you use that setup each time, maybe that's something else you guys can put on a note card to use for studying. That can help you determine what each part means. Let me make sure the key's right. The questions on this question. Okay, questions on others. Rita? Okay, lesson 1516, number 1. Okay, the one that says select all. Okay. So select all of the quadratic expressions that are in vertex form. Is the first one in vertex form? What does the equation look like for vertex form? Okay, perfect. So one of the things you need to memorize, put on your note card, knowing that HK would be your vertex. Does the first one look like it's in that form? So then I would pick it. Does the second one? So I'm gonna go with, it could be, because I could still tell the vertex from this. Like I know my vertex will be 0, 4, -4. So I'm gonna pick it and we'll just see what the key says, although it could also be considered standard form too. Is this one vertex form? Okay, definitely not, because it doesn't have that squared part. In vertex form, you should see a squared, whether it's on the X or outside the parentheses where the X is, you should definitely still see that. So we're definitely not gonna pick this one. Would this one be in vertex form? I'm gonna go with yes, because I can identify the vertex as -3, 0. So I'm gonna go with yes on that one. Is the last one in vertex form? Yeah, because it looks like this. When A is 1, we don't usually write the A. When H is 0, we don't usually write anything in parentheses with yes. When K is 0, we don't usually add or subtract anything from it. So I'm gonna go with that, it's all 4 of these, and that's right. The only one that's definitely not is this one, because it doesn't have a square shown. Under text form for sure would have it. So good on this one. This is 1516 number 1, if you were wanting that answer. All right, other questions from anything, Romina? Number 2 on today. So let's see. We have a bunch of different graphs and we want to compare them. So how do they compare? The shape is, how would you describe the shapes as same or different? Do you think any of them are like wider or narrow than the others? So you would say the shape is the same, that's what it means. And if you look at the equation, none of them should be more wide or narrow because all of them have an A value of 1. So the shape is the same, but they're all in blank locations. Different locations. How does the -5 in the x squared minus 5 affect the graph? Subtracting 5 from the square term shifts the graph in what direction? Down, good. We learned that. In yesterday's lesson for the first time, but yes, it would. How does the +2 and the -8 in x plus 2 squared minus 8 affect the graph? So adding 2 to the x before squaring it shifts the graph in what direction? Left. If it says x plus a number, yes, it shifts to the left. And subtracting 8 shifts it in what direction? Down. Let's see if that's right, and it is. But does that make sense? When in doubt, you could always, like on your test, just like how we did in the lesson, you could play around with the numbers to see, okay, just plussing it in the parentheses, move it left or right, and then you can make a better determination on your test. All right, other questions at all? Can you move me from the study guide if you are that far? Number 3. On today. All right. So which equation? Which equation represents this graph moved 3 units to the left? So how do I want to answer this? I think what they're trying to show you or get you to realize is that when you do something to the x inside the parentheses before squaring it, it moves things left or right. So if it's moving 3 units to the left, what would need to be in the parentheses? Table 7, not 1. 3 and plus or minus. If I want to go left, plus. So that's what I think it's trying to say. And then because there's multiple x's, I think it only wants it in the one before it's squared. That's what I'm gonna go with. I've not really done one like this before. So I think based on what we learned yesterday, adding a number to the x before squaring it would move it to the left. So I would pick this one. So let me see what the answer is. Okay, let me keep thinking. Would I need to do it to all of them? Or should it be this one? Okay, let me check the key just in case. To make sure this key isn't wrong. This is lesson 17. Okay, yeah, that's right. So if you're changing the X in one location, you need to change it in all locations. So this is right. Okay? Other questions at all? Might have time for one more, depending on how long it is. You just let me know then, but yeah, that's right.